outside the gravitational influence of the galactic bar. The structure of the interstellar medium and stars in the disk of the Milky Way is organized into 4 spiral arms. Spiral arms typically contain a higher density of interstellar gas and dust than the galactic average, as well as a greater concentration of star formation, as traced by H2 regions and molecular clouds. The Milky Way's spiral structure is uncertain, and there is currently no consensus on the nature of the Milky Way's arms. Perfect logarithmic spiral patterns only crudely describe features near the Sun, because galaxies commonly have arms that branch, merge, twist unexpectedly, and feature a degree of irregularity. The possible scenario of the Sun within a spur, local arm, emphasizes that point and indicates that such features are probably not unique, and exist elsewhere in the Milky Way. Estimates of the pitch angle of the arms range from about 7 degrees to 25 degrees. There are thought to be 4 spiral arms that all start near the Milky Way galaxy's center. These are named as follows, with the positions of the arms shown in the image below. 2 spiral arms. The Scutum-Centaurus arm and the Carina-Sagittarius arm have tangent points inside the Sun's orbit about the center of the Milky Way. If these arms contain an overdensity of stars compared to the average density of stars in the galactic disk, it would be detectable by counting the stars near the tangent point. 2 surveys of near-infrared light, which is sensitive primarily to red giants and not affected by dust extinction, detected the predicted overabundance in the Scutum-Centaurus arm but not in the Carina-Sagittarius arm. The Scutum-Centaurus arm contains approximately 30% more red giants than would be expected in the absence of a spiral arm. This observation suggests that the Milky Way possesses only 2 major stellar arms, the Perseus arm and the Scutum-Centaurus arm. The rest of the arms contain excess gas but not excess old stars. In December 2013, astronomers found that the distribution of young stars and star-forming regions matches the 4-arm spiral description of the Milky Way. Thus, the Milky Way appears to have 2 spiral arms as traced by old stars and 4 spiral arms as traced by gas and young stars. The explanation for this apparent discrepancy is unclear. Quote, the near 3 kpc arm, also called the expanding 3 kpc arm or simply the 3 kpc arm, was discovered in the 1950s by astronomer Van Woerden and collaborators through 21 cm radio measurements of high atomic hydrogen. It was found to be expanding away from the central bulge at more than 50 km per second. It is located in the 4th galactic quadrant at a distance of about 5.2 kpc from the Sun and 3.3 kpc from the Galactic Center. The far 3 kpc arm was discovered in 2008 by astronomer Tom Dame. Center for Astrophysics, Harvard and Smithsonian. It is located in the 1st galactic quadrant at a distance of 3 kpc, about 10,000 light-years, from the Galactic Center. A simulation published in 2011 suggested that the Milky Way may have obtained its spiral arm structure as a result of repeated collisions with the Sagittarius dwarf elliptical galaxy. It has been suggested that the Milky Way contains 2 different spiral patterns. An inner one, formed by the Sagittarius arm, that rotates fast, and an outer one, formed by the Carina and Perseus arms, whose rotation velocity is slower and whose arms are tightly wound. In this scenario, suggested by numerical simulations of the dynamics of the different spiral arms, the outer pattern would form an outer pseudoring, and the 2 patterns would be connected by the Cygnus arm. Outside of the major spiral arms is the Monoceros ring, or outer ring, a ring of gas and stars torn from other galaxies billions of years ago. However, several members of the scientific community recently restated their position, affirming the Monoceros structure is nothing more than an overdensity produced by the flared and warped thick disk of the Milky Way. The structure of the Milky Way, S disk is warped along an S curve.